Hi, welcome back to my class in Analytic Geometry. For today's lesson, we will take examples for using the two-point form of equation of a line. That is, we will find an equation of a line through the given points. That is, 2 points are given and we will find the equation of the line passing through the two given points, and we will use the two-point form of equation of a line. Also, we will define slope in terms of a trigonometric function which you must have taken from your course in plane trigonometry, and we will also apply the slope point form of equation of a line to find the equation of a line whose slope is given and 1 point on the line. For our first example, consider the following problem. Find the equation of the line through 3, -2, and -4, 1. Find the slope of the line and draw the line. In this problem, the given are 2 points, 3, -2, and -4, 1. And given the 2 points, we want to find the equation of the line passing through these two given points. We are also asked to find the slope of the line. Now, to find the slope of the line, we can do it using the formula for slope denoted by m, or we can get the slope of the line from the equation of the line after we have found the equation of the line. And then we finally draw the line. To draw the line, either you plot these 2 points in the Cartesian plane and connect them with a straight line. But we will draw the line by finding the intercepts of the line from its equation and then connecting these intercepts with a straight line. Now, to find the equation of the line passing through these two given points, we use the two-point form of equation of a line, given by the following. We have y minus y1 equals y2 minus y1 over x2 minus x1 multiplied by x minus x1. This is the two-point form of equation of a line. If you are given 2 points on the line and you are asked to find the equation of the line, use this two-point form of equation of the line. And the 2 points are denoted by P1 and P2. The first point has coordinates x1, y1. And the second point has coordinates x2, y2. You can take any of the 2 points as your point P1. If you take this point as the point P1, then this will be your point P2. But you can also take this point as your first point P1, and this will be your point P2. I will take this point with coordinates 3, -2 as the point P1. So our point P1 with coordinates x1, y1 is the first given point, 3, -2. And this implies that the abscissa x1 of the first point P1 is 3. x1 is 3. And the ordinate y1 of the first point P1 is negative 2. y1 is negative 2. Because we have taken the first given point as the point P1, then the second point given will be our point P2. Our point P2 with coordinates x2, y2 is the point with coordinates negative 4, 1. This implies that the abscissa x2 of the second point P2 is negative 4. We write x2 equals negative 4. And the ordinate y2 of the second point P2 is equal to 1. We write y2 equals 1. Now we substitute these values of x and y into this equation for the two-point form of equation of the line. We start from the left. We have y minus y1. Our y1 is negative 2. Since we have minus here and our y1 is negative 2, we write negative 2 in open close parentheses. At the right hand side, we have y2 minus y1. y2 is 1 minus y1 is negative 2. Again, we write negative 2 in open close parentheses. Divide by x2. Our x2 is negative 4 minus x1. Our x1 is 3. Multiply by x minus x1. Our x1 is 3 minus 3. The next step is to simplify this equation by removing the grouping symbols, and we will write the equation of the line through these two given points in standard form or general form. The standard form or general form of equation of a line is given by the following. We have ax plus by plus c equals 0. This is the general form of the equation of the line. Ax plus by plus c equals 0. This equation is also known as the standard form of the equation of the line. We simplify. Negative multiplied by negative is positive. We have y plus 2 equals 1. Negative times negative is positive, plus 2. Divide by negative 4 minus 3 is negative 7. Multiply by x minus 3. The left hand side y plus 2 we multiply by negative 7 to simplify further until we have written the equation of the line in this general form. We have y, we have negative 7 multiplied by y plus 2 equals 1 plus 2 is 3 multiplied by x minus 3. We remove the grouping symbols by applying the distributive property of multiplication. We multiply each term of this binomial by negative 7. Negative 7 multiplied by y is negative 7y. Negative 7 multiplied by positive 2 is negative 14. Equals, we have 3 multiplied by x is 3x. And positive 3 multiplied by negative 3 is negative 9. Next, we transpose 3x and negative 9 to the left-hand side. If you do that, the coefficient of x when transposed to the left-hand side will become negative 3x, negative 3. And it's better that the coefficient of x be a positive numerical coefficient. And to make the coefficient of x positive, if you transpose 3x to the left-hand side, you multiply the equation by negative 1 after the transposition. But instead of doing that, I will transpose negative 7y and negative 14 to the other side of the equation, so that the coefficient of x remains positive 3. We have 3x minus 9 . Transpose negative 7y to the other side. When you transpose, we take the opposite sign of the term. Hence, negative 7y after transposition becomes positive 7y. We also transpose negative 14 to the right-hand side, and we take the opposite side sign of negative 14. It becomes positive 14. And nothing is left at this side of the equation. Now, the first term in general form is the term containing x. So 3x is our first term, followed by the term containing y. So after 3x, we write plus 7y. And the last term is the constant term. We combine the constant here. The constant is negative 9 plus 14 is 5. Equals 0. This is the equation of the line that passes through the point negative point 3, negative 2, and the point negative 4, 1. To check if you have obtained the correct equation of the line, you substitute the coordinates of these points for x and y into this equation, and they must satisfy this equation. And we will do that. To check our answer, to check whether this is really the equation of the line passing through these 2 points given, we take each point and we substitute the coordinates of each point for x and y into this equation, and this equation must be satisfied. That is, if these points are points on the line, then the coordinates of these points must satisfy the equation of the line. We start with the first point, 3, negative 2. And we write checking. This is how you check your solution. The first point, 3, negative 2. We take this as the point xy, which implies that x is 3 and y is negative 2. If this point is a point on the line with this equation, then these values of x and y, the coordinates of this point, must satisfy this equation. So we now substitute these values of x and y into this equation. We have 3 multiplied by x is 3, plus 7 multiplied by y is negative 2, plus 5. We want to check if this will give us a total of 0. We have 3 multiplied by 3 is 9. Positive multiplied by negative is negative. 7 multiplied by 2 is 14. Plus 5, is that equal to 0? We have 9 minus 14 is negative 5. Plus 5 is 0. Thus, the coordinate of this point satisfy the equation of the line. We conclude therefore that this point is really on the line with this equation, 3x plus 7y plus 5 equals 0. Now we do the same for the second point, negative 4, 1. If this point is on the line, whose equation is given by this equation in general form, the coordinates of this point must satisfy this equation. We take this point, negative 4, 1, as the point xy. Negative 4, 1 as the point xy. This implies our x now is negative 4. And our y is 1. And we substitute these values of x and y into the equation of the line. We have 3 multiplied by x is negative 4, plus 7 multiplied by y is 1, plus 5 equals 0. And we want to check if this sum will be equal to 0. We have 3 multiplied by negative 4 is negative 12, plus 7 multiplied by 1 is 7, plus 5. We want to check if that will give us a sum of 0. And negative 12 plus 7 is negative 5. And negative 5 plus 5 is 0. Hence, the equation of the line is satisfied by the coordinates of the second point given, negative 4, 1. Thus, we conclude that this point is really on the line whose equation is 3x plus 7y plus 5 equals 0. Therefore, we conclude that this equation of the line through these 2 points is correct, because we have shown that the coordinates of these points that are on the line satisfy the equation of the line. Now we will find the slope of the line using a formula. The slope of a line is denoted by small letter m, and by formula, the slope m of a line is given by the following. M slope is equal to y2 minus y1. This is the difference of the ordinates of the 2 points divided by x2 minus x1, or the difference of the abscissas of the 2 points. If 2 points on the line are given, or if you know 2 points that are on the line, you can find the slope of the line using this formula, where the 2 points have coordinates x1, y1 for the first point, and the second point has coordinates x2, y2. As we did earlier, we take the first point P1 with coordinates x1, y1 as the given point 3, negative 2. The first point 3, negative 2, we have taken as the first point P1 with coordinates x1, y1, which implies that x1 is 3 and y1 equals negative 2. If this is our first point, then the second point, negative 4, 1, is our point P2 with coordinates x2, y2, which is equal to the point negative 4, 1, which implies that x2 equals negative 4, and the ordinate y2 of the second point P2 is equal to 1. We now substitute these values of x and y into the formula for slope m of a line. Equals y2 is 1 minus y1 is negative 2. Because we have minus here and our y1 is negative 2, we write negative 2 in open close parentheses. Divide by x2. x2 is negative 4. Minus x1. x1 is 3. We simplify. Numerator, we have 1. Negative times negative is positive, plus 2. And negative 4 minus 3 is negative 7, which is equal to 1 plus 2 is 3. Divide by negative 7. Or you can write negative 3 over 7. You should obtain the same value for m if you take negative 4, 1 as the point P1 with coordinates x1, y1. If you take this as the first point P1, then x1 will be negative 4 and y1 will be positive 1. If you take this as the first point P1, then this point will be your point P2 with coordinates x2, y2, which implies that your x2 will be 3, your y2 will be negative 2. And when you substitute the values of x and y into the formula for slope m, you should get the same value, negative 3 over 7. Try it. Now, if you know the equation of the line, you do not have to calculate the slope of the line using this method. You can get the slope of the line from its equation by writing the equation of the line in a slope-intercept form. And we will take that as method 2. For method 2, if the equation of the line is given, we get the slope of the line from the equation of the line by writing the equation of the line in slope-intercept form. And the slope-intercept form of equation of the line is given by the following. We have y equals mx plus b. This is what you call the slope-intercept form of the equation of a line, where b is the y-intercept, which is the point of intersection of the line, and the vertical axis y. And m, of course, is the slope of the line. Later on, we will formally define slope, and we will show how this formula for slope was obtained. But for now, we write this equation. This equation of the line is in general form. We write that in this form known as slope-intercept form. After writing this equation in slope-intercept form, whatever the coefficient of x will be the slope of the line. And to write this equation of the line in general form, in slope-intercept form, simply solve for y from this equation in terms of x. That is, you must have y only one side of the equation with coefficient of 1. And all the other terms should be on the other side of the equation. Hence, we start by transposing 3x and positive 5 to the other side. And we are left with 7y at the left-hand side. We have 7y equals 3x transposed to the other side. We get negative 3x plus 5 transposed to the other side. We get negative 5. And the coefficient of y in slope-intercept form is positive 1. We divide now both sides of this equation by 7. And 7 will cancel out from the left-hand side. We have y equals, now to divide the numerator by 7 is to divide each term of the binomial in the numerator by 7. We have negative 3x divided by 7 minus 5 divided by 7. This now is the slope-intercept form of the equation of the line. This equation and this equation are the same equation of the line, passing through these 2 points, but they are written in different forms. This is the general form of the equation of the line, and this is the slope-intercept form of the equation of the line. Now, by inspection, you check the coefficient of x, and you can see that the coefficient of x is negative 3 over 7. And comparing that with this slope-intercept form of the equation of the line, it means that the slope of the line is the coefficient of x, m equals negative 3 over 7. Which is the same result we obtained in method 1 using the formula for obtaining the slope of a line. Again, if 2 points on the line are given, you can calculate for the slope of the line using this formula for m, which denotes slope. Or if you know the equation of the line, you write the equation of the line in slope-intercept form, and the coefficient of x will be the slope of the line. Next, we will now sketch the line. We draw the line passing through these 2 points with equation 3x plus 7y plus 5, and we will draw the line by plotting, by finding first the intercepts of the line, and we plot these intercepts in the Cartesian plane, and we connect these intercepts with a straight line. We now draw the line passing through the points 3, -2, -4, 1, whose equation we have shown is 3x plus 7y plus 5 equals 0. Again, as I said earlier, you can draw the line by plotting these points in the Cartesian plane and connecting them with a straight line. And that line has equation 3x plus 7y plus 5 equals 0. But what we will do now to draw the line is to find the intercepts of the line from its equation, and we connect the intercepts with straight line. We draw the line in the Cartesian plane that consists of 2 axes. The vertical axis is denoted by y, and we call it the y-axis. The horizontal axis is denoted by x, and we call it the x-axis. At the intersection of the 2 axes is a point which we denote by 0, and we call it the origin. Now we start with the x-intercept. The x-intercept is a point on the x-axis, and we know that any point on the x-axis, the ordinate or the value of y of any point on the x-axis is 0. Thus, to find the x-intercept or the point of intersection of the line and the x-axis, you set y to 0. If y is 0, we substitute y equals 0 into the equation of the line. We have 3x plus 7 multiplied by y is 0, The 7y will go, and we get 3x plus 5 equals 0. Now, this is what you call a linear equation in one variable x. And you solve for x from this equation by transposing first positive 5 to the other side. At the left-hand side, we have 3x equals positive 5 transposed to the other side, -5. And divide both sides of the equation by 3. And 3 will cancel out from the left-hand side, and we get x equals -5 over 3. Now, using your calculator, you divide -5 by 3, or divide 5 by 3, you should get 1.666. 6 is repeated without end. So the value of x here is a non-terminating repeating decimal number. And we always give the final answer to 2 decimal number. The third digit from the decimal point is to be rounded off. Thus, you count 3 from the decimal point, 1, 2, 3, and 6 is to be rounded off. Since the number to be rounded off is more than 5, we add 1 to the preceding digit, which is also 6. That is, the rule says if the number to be rounded off is 5 or more, add 1 to the preceding digit, the digit that comes before the number to be rounded off. The number to be rounded off is 6, and 6 is more than 5. So we add 1 to the preceding digit 6. 6 plus 1 is 7. Hence the value of x to two decimal places is negative 1.67. We plot this value of x in the horizontal axis. Since it is negative, it is to the left of the y-axis. And we approximate negative 1.67. At this point, the value of y is 0, as we have assigned 0 to y. So the coordinates of this point are negative 1.67, 0. And the line will pass through this point on the x-axis. This point is the point of intersection of the x-axis and the line through this point and this point, whose equation is given by this equation. And we call this point x-intercept. Next, we find the y-intercept of the line with this equation. The y-intercept is a point on the y-axis. The y-intercept is the point of intersection of the line and the y-axis. Since the y-intercept is a point on the y-axis, the abscissa of the y-intercept x is 0. Because any point on the y-axis, the abscissa x is 0. Thus, to find the y-intercept of the line, you set x to 0. If x equals 0, we substitute x equals 0 into the equation of the line. If x equals 0, 3x will go, because 3 multiplied by x is 0 is 0. And we are left with 7y plus 5 at the left hand side equals 0. 7y plus 5 equals 0. Again, this is a linear equation in one variable y, from which we solve for y by transposing positive 5 to the right hand side. And we have 7y equals, transpose positive 5 to the right hand side, take the opposite sign of positive 5. We get negative 5. Finally, we divide both sides of this equation by 7. And 7 will cancel out from the left. And we get y equals negative 5 over 7. And using your calculator, you divide 5 by 7 and its sign is negative. 5 by 7 is equal to 0.71428571. For 28571. Use your calculator, you divide 5 by 7 and you should get negative 0.71428571 for 28571. Now we round this up to two decimal places. The digit to be rounded off is the third digit from the decimal point. From the decimal point you count 3, 1, 2, 3. The number to be dropped is 4. Since the number to be rounded off is less than 5, we do not add 1 to the preceding digit 1. 1 is retained. And we drop 4 and all the digits to its right. Hence, y equals negative 0.71 to 2 decimal places. And we plot this point in the y-axis. Again, we approximate. This is negative 0.71. The coordinates of this point are 0 and negative 0.71. Abscissa is x because abscissa is 0 because we assign 0 to x. Hence, the coordinates of this point are 0 and negative 0.71. And the line will pass through this point on the y-axis. Hence, this is the point of intersection of the line and the y-axis, and we call this point y-intercept. After you have found the x-intercept and the y-intercept of the line, connect the two intercepts with the straight line. This is the line passing through the point 3, negative 2, negative 4, 1. And the equation of this line is 3x plus 7y plus 5 equals 0. It is best that you label the line with its equation. And this line has equation 3x plus 7y plus 5 equals 0. Before we formally define slope of a line, let us interpret the value of the slope we have obtained earlier. Earlier, we have shown that the slope of this line with equation 3x plus 7y plus 5 equals 0 is negative 3 over 7. This negative 3 over 7 can be written as negative 3 divided by positive 7, or negative 3 over 7 can be written as positive 3 divided by negative 7. Now we interpret the value of the slope m. If you write the slope m as negative 3 divided by 7, this means that if the value of x abscissa of the point on the line changes by 7 units, the value of the ordinate of the point also on the line will decrease by 3 units. Let us consider this point 3, negative 2, which is a point on this line. 3, negative 2. If the abscissa increases by 7 units, then the abscissa of the new point on the line will be 3 plus 7 is 10. The abscissa increases by 7 units. We have 3 plus 7. The abscissa of the new point on the line is 10 units. The slope says that the ordinate of the new point on the line will decrease by 3 units. Hence, from this point, negative 2 minus 3, you get negative 5. Again, the slope m equals negative 3 over 7 means that if the abscissa of the point, if the value of x increases by 7 units from 3 to 10, obtained by 3 by adding 7 is 10. The value of the y coordinate will decrease by 3 units. We have minus 2 minus 3 equals negative 5. This point 10, negative 5 is also a point on the line. Now let us check if this is a point on the line. As we said earlier, if the point is on the line, then the coordinates of the point must satisfy the equation of the line. For x, we substitute 10 for x, and we substitute negative 5 for y. And if we simplify, we should get a sum of 0. We check, we have 3 multiplied by x. Our x is 10. Plus 7 multiplied by y. Our y is negative 5. Plus 7 multiplied by negative 5. Plus 5. We check if this is 0. We have 3 by 10 is 30. Plus 5 is 35. And 7 multiplied by negative 5 is negative 35. And 35 minus 35 is 0. Thus, this point is really a point on this line. Now, if you write the slope negative 3 over 7 as positive 3 divided by negative 7, this means that if the value of x, the abscissa of the point, is decreased by 7 units, the ordinate of the point will increase by 3 units. Let us take again this point 3, negative 2 as the original point on the line. And using the slope of the line written in this way, positive 3 divided by negative 7, which says that if the abscissa or the value of x is decreased by 7 units, we have 3 minus 7 is negative 4. Then the ordinate of the point will increase by 3 units. We have negative 2 plus 3 is 1. And we obtain the new point on the line. Again, using the slope m in this form, positive 3 divided by negative 7, it means that if the abscissa of the point is decreased by negative 7, 3 minus 7 is negative 4. The ordinate y, negative 2, will increase by 3 units. We have negative 2 plus 3 is 1. And we obtain the new point on the line. Now we check if this is really a point on the line. We said that if this is a point on the line, the coordinates of this point must satisfy the equation of the line. And to check that, we replace x with, in the equation of the line, we replace x with negative 4, and we replace y with positive 1. We have 3 multiplied by x. Our x is negative 4 plus 7 multiplied by y. Our y is 1 plus 5. To check if this is 0. We have positive 3 multiplied by negative 4 is negative 12. We have 7 multiplied by 1 is 7 plus 5 is 12. And negative 12 plus 12 is 0. Thus, this point negative 4, 1 is really a point on the line. And that's how we interpret the slope m of a line. Now we will formally define slope of the line. Before we formally define slope of a line, please try the following exercises for your practice in finding the equation of the line given 2 points on the line. Consider the following. Find the equation of the line through the 2 given points. Find the slope of the line using 2 methods. The first method is using this formula for slope denoted by m, and the second method is by writing the equation of the line in general form in slope-intercept form. First, you find in method 2, you find first the equation of the line through the 2 given points, and you write that equation in general form. And that general form of the equation of the line you write in slope-intercept form, and that will be for method 2. And after you obtain the slope of the line, interpret the slope of the line as I have shown earlier in our example, and draw the line. In number 1, the 2 given points are 0, -5, and -1, 2. You find the equation of the line through this, passing through these 2 points, and you will use the 2-point form of equation of the line. You can take either of the 2 points as the point P1. In number 2, the 2 points are -3, 2, and 0, 1/2. Again, you find the equation of the line through these 2 points using the 2-point form of equation of a line. You can take this point or this point as your point P1 with coordinates x1 and y1. And in number 3, for your practice, the 2 given points are 3, 2, and -1, -4. To find the equation of the line passing through these 2 points, again, you use the 2-point form of the equation of the line. And you can take this point or this point as your first point P1 with coordinates x1 and y1. And to draw the line, we use the method I have demonstrated earlier. You find the x and the y intercepts of the line from using the general form of the equation of the line, and connect the intercepts of the line with a straight line. And don't forget to label the horizontal and the vertical axis with x and y respectively. Also, don't forget to label the line with its equation. Now, we define slope, and our definition of slope uses a trigonometric function which you must have taken from your course in plane trigonometry or even in geometry. The slope is defined as the tangent of the angle of inclination of the line with respect to the horizontal line or horizontal plane. We write slope is defined as the tangent of the angle of inclination of the line with the horizontal axis or plane. Now, I will show you geometrically what is meant by the angle of inclination, and from that geometric representation of this angle of inclination, I will show you how this formula for calculating the slope of a line denoted by m was derived. Consider the following line. If we do not know the equation of the line and we want to solve for the slope of the given line, we need 2 points on the line. Thus, we find the slope of this line whose equation is unknown, and we do that by taking two arbitrary points on the line. And we denote these points by points P1 and P2. We let this be point P1 and we let this be point P2. And each point has two coordinates. For the point P2, we denote the coordinates of the point P2 by x2, y2. For the coordinates of the point P1, we denote the coordinates of this point by x1, y1. Now, this is the horizontal axis, and the slope of this line is defined as the tangent of the angle of inclination of this line with respect to the horizontal axis. And we draw a line intersecting this given line and parallel with the horizontal axis. I will draw that line intersecting this given line at the point P1 and parallel with the x-axis, and this is the line. This line is parallel with the x-axis and it intersects the given line at the point P1. And this angle of inclination mentioned in the definition of the slope is this angle. We denote this by the angle theta. So the slope of this line is defined as the tangent of this angle theta. And angle theta is the angle of inclination of the line with respect to the horizontal. You can draw any line through the given line parallel with the horizontal axis. Suppose you draw the line, instead of this line, you draw this line. And the angle of inclination of this line will be this angle. Suppose this is angle theta 1. But the angle theta is equal to the angle theta 1. This means that the angle of inclination of the line is the same, regardless of the line you draw, intersecting the given line and parallel with the x-axis or horizontal axis. Now, this angle theta and theta 1 are equal because from geometry we have a theorem that says if two parallel lines are cut by a transversal, now this line and this line are parallel. And the given line here is our transversal line. The transversal line cuts these parallel lines. And the theorem says from geometry that if two parallel lines are cut by a transversal line, the corresponding angles are congruent, which means that the measure of this angle theta and angle theta 1 are equal. Hence, this angle of inclination theta and this angle of inclination theta 1 are the same and equal angle. But I will use theta. Now, to get the tangent of the angle theta, we construct a right triangle because the values of the values of the six basic trigonometric functions of an angle is based from an acute angle of a right triangle. From the point P2, we project a perpendicular to this line. we drop a perpendicular to the first line we have drawn parallel with the x-axis. Because this line is perpendicular to this line, they intersect at right angle. Now we have drawn a right triangle, and the angle theta here is an acute angle. And with respect to this acute angle theta, the side opposite this acute angle theta is this side. And we find the length of this side. The length of this side is equal to this side, which is y2 y2 is the distance of point P2 from the x-axis. So the length of this side opposite the angle theta is equal to this side y2 minus this length, which is the distance of the point P1 from the x-axis, and is given by y1 minus y1. Again, this side of the right triangle opposite the acute angle theta, or the angle of inclination of the line, is given by this length y2, the distance of the point P2 from the x-axis, given by the ordinate y2 of P2 minus this length, which is equal to the distance of the point P1 from the x-axis, and is given by y1. Now we obtained for the tangent, we need the opposite side and the adjacent side. The side adjacent to the acute angle theta is this side of the right triangle. This is the side that makes the acute angle theta, or this is the side that makes the angle of inclination of the line with the hypotenuse of this right triangle. And we find the length of this adjacent side of this right triangle. This length is equal to this length. The distance of this length is equal to this length. And the distance of P2 from the y-axis is given by x2. And from this length, which is equal to x2, the distance of P2 from the y-axis, x2, we have to subtract this length. And this length is given by the distance of the point P1 from the y-axis, and is given by x1 minus x1. Again, the adjacent side of the side adjacent to this angle of inclination of the line is equal to this length, which is equal to this, and is equal to the distance of P2 from the y-axis, and is given by x2 minus this length, which is the distance of P1 from the y-axis, and is given by x1. Hence, the adjacent side is x2 minus x1. Now, we can write the tangent of the angle of inclination of the line theta. The slope m is defined as the tangent of the angle of inclination of the line, we denoted by theta. And from plane geometry, tangent of an angle, acute angle theta, is defined as the ratio of the opposite side to the adjacent side. Hence, the slope m equals opposite side, the side opposite the angle of inclination. In our diagram, it's given by y2 minus y1. Divide by the side adjacent to the angle of inclination, and is given by x2 minus x1. This is often denoted by delta y. over delta x, which is often written as rise over run. Thus, we have shown that the slope of the line passing through these 2 points P1 and P2 is given by this formula: y2 minus y1 divided by x2 minus x1. And the difference between the ordinates of the 2 points on the line is denoted by delta y, known as the change in y, and the difference between the abscissas of the 2 points on the line is denoted by delta x, or the change in the values of x. And this ratio is also known as the rise over run. In our next lesson, we will have problems that will require us to find the equation of the line given the slope of the line and 1 point on the line. If you have question about the lesson today, you ask your questions in the comments below, and don't forget to subscribe to my YouTube channel, Art Calizon. Thank you.